Hello, ladies and gentlemen. We are going to start chapter 14, which is just a little bit of an extension of chapter 13. So we're going to still be working in our unit circle. So our objectives today are to be able to graph the periodic function sine by hand and in your grapher, okay, and be able to label our graph well. So the first thing that I want to do is I want to define a periodic function. Okay, so great examples of this in science would be the lunar patterns. So the cycles of the moon, they continue or they repeat every month. Tidal patterns, okay, the waves have a pattern to them of when the tide goes out, when the tide comes in. Those would be kind of cool classic examples of a periodic function in science. All right, so our basic definition then for a periodic function is a graph, or I guess I could say a function, whose pattern repeats over a specific pattern, or I guess I should say a specific interval. Okay. So for the lunar pattern, so the cycles of the moon, it would repeat every month, give or take a little bit. And the same with our tidal patterns because they're actually driven by the cycles of the moon. Alrighty, so let me show you what a periodic function looks like. So I don't know what this would be a graph of, it's just kind of a silly example to illustrate the point. So if this is my x and y axis, and I had a graph that looks kind of like this, what you would notice is that in general, my pattern keeps repeating, okay? So that would be a repeating pattern in theory, and it would go on forever in both directions. It's just easier for me to draw to the right. So a couple of things that I need you to notice about this particular pattern is if I choose a point to track, so if I track this point, that point happens again right there. This would be considered one cycle. Okay, so I'm going to write one cycle. From the top of the graph to the bottom of the graph, that's going to be considered the amplitude. Okay, so those are kind of some of the words that we're going to use as we describe our periodic functions. So let me just start writing those definitions down. Okay, a cycle is going to be defined as one complete pattern. So we are going to deal with some very symmetric, very polite little curvy patterns, but cycles don't always have to be pretty and curvy. The period is going to be the horizontal length of one cycle. Okay, so there's two of my definitions. The amplitude basically is describing the height of our curves, okay? All right, so notice that I went on our little graph, I went from the very top to the very bottom to describe my amplitude. So I'm going to describe it as 1/2 the maximum y value minus the minimum y value. And I'm going to put little y's down there so you know I'm talking about the vertical. Okay, and then my x-intercepts, same thing that they've been forever, are going to be where my graph crosses the x-axis. Okay, so x-intercepts are always the same thing, no matter what the function looks like. All right, so to start our example, I want to go back and review our unit circle. And I want to just talk about the quadrantal angles. So I only want to talk about the angles that are sitting on the axes. So here's my little unit circle. Remember that our unit circle has a radius of 1. And I'm going to do my angles in radians. So this is 0, this is pi over 2, this is pi, and then this is 3 pi over 2. All the way around the circle is 2 pi. The coordinates at this point are 1, 0. At this point it's 0, 1. Over here it's a -1, 0. Down here it's a 0, -1. And then all the way back around. Remember that our coordinates are x, y, because that's the rectangular coordinate system. Next year I'll teach you a new coordinate system. And remember that also means the cosine of the angle, the sine of the angle. Okay, since we're going to be talking about things rotating in circles. So now what I want to do is I want to graph f of x is equal to the sine of theta, or sometimes we would say, I guess it would have been more appropriate to say f of theta. F of x is equal to the sine of x. So since I'm only going to graph sine, I'm only going to look at the y coordinates at each of the angles. And here's what my graph would look like if I stretch it out. Okay? Notice that for sine and cosine, they oscillate, cool word, between a -1 and a +1. So notice that all of these values are either a 1, a -1, or a 0. So it's oscillating between those two values. So I'm going to start at 0, and I notice that the sine is 0. Okay, so I'm looking at the y coordinate. My next tick mark would be pi over 2. Okay, at pi over 2, my y value is 1, so I'm going to put a dot there. My next tick mark is pi. At pi, sine is 0. Remember, I'm looking at the y coordinate. My next tick mark would be 3 pi over 2. At 3 pi over 2, sine is a -1. And then my last tick mark would be 2 pi. Now I've gone all the way around the circle, and at 2 pi, sine is 0. So now I want to connect my dots. Ooh, almost fell off my little chair. Alrighty, and I'm going to start at 0, and I'm going to connect my dots, and there's my graph. So what that does is that tells me some entertaining things about my sine graph. For starters, notice that it's oscillating between a -1 and 1. The length of one complete cycle is 2 pi, so we would say that the period is going to be 2 pi for sine for the standard graph. And notice that my amplitude would be 1/2 of 1 plus 1. Okay, so that would be 1/2 of 2, which is 1. So my amplitude is 1. So it's the average of the top and the bottom. Alrighty, so now what I want to do is just use some information to talk about our generic equations, and then I want to do some graphing for you on the calculator to illustrate some points. So this is a generic equation. I guess a more appropriate word would be the standard form. And I'm going to write y is equal to a sine b theta. Okay? So the things that these affect, a is my vertical stretch factor, which means that it stretches the graph vertically. So it makes it taller, all right, in both directions. It also then is going to affect the amplitude. Okay? B is technically a horizontal stretch factor, but all we're going to say is that it's the number of cycles that happen by 2 pi, because the period or one complete cycle for sine is 2 pi in its standard form. Alrighty. When we talk about amplitude, we always talk about the absolute value. And remember that if my vertical stretch factor is negative, so let's say I had y is equal to a negative sine theta, and I'm just going to draw a quick sketch. Instead of having my sine graph start up, it's going to flip my graph or reflect it across the x-axis. So just like every other graph that we've done this year, when I have a negative a, the negative reflects the graph across the x-axis. Alrighty. So now what I'm going to do is I'm going to graph a series of equations for you and show you kind of what happens when I change either the amplitude or the number of cycles. So first let's graph y is equal to the sine of theta. Let me clear all my stuff. So if I go to my mode button first, you cannot graph sine, cosine, tangent unless your calculator is in radians. So first you have to change it to radians. And then because my calculator was in a different mode, I make sure that it's back in function mode. Now I'm going to go to my window, and I'm going to just show you what I'm doing. So I'm going to graph from a -2 second pi to a positive 2 pi. So I'm going to get one negative cycle and one positive cycle. Okay. I want my y min and max to be a -2 and 2. And then all that does is just kind of define the window to illustrate what I'm doing. And I'm actually going to change this to 3.5 and 3.5. You don't have to worry about the window settings. You can always do a zoom 6, but for illustration purposes, I'm showing you what I'm doing. All right, so now I'm going to go to my y equals, and I'm going to enter the sine of theta. So when I'm in function mode, the variable that my calculator uses is x. Okay, and I'm going to hit graph. So here comes the -1, and there's the +1. Okay, so this is starting at 0. This is at pi over 2, this is pi, this is a 3 pi over 2, and this is 2 pi. So I'm showing you two cycles, one negative and one positive. So the first thing that I'm going to do is I'm going to show you what happens when I enter the negative sine theta. So I'm going to always keep the original. Now I'm going to enter a negative sine theta and a graph again. So the new graph, pretty cool, is reflecting. So this was the original, this is the reflection. So every point is reflecting across the x-axis. So that was pretty cool. Okay. Now I'm going to enter y is equal to 3 sine theta. So the 3 is my amplitude. So what it's going to do to my graph is it's going to make it get taller. So I'm going to enter 3 sine theta, okay, and graph. So here's the original, y is equal to the sine of theta. Now here goes the stretched amplitude. Pretty cool. So let's talk about a couple of things. Notice that I was changing the vertical. So notice this is the original graph, this is the new graph. Also notice that I haven't changed where my graph crosses the x-axis. So I did not change my b value, or the number of cycles. The only effect that this had on the graph is that it stretched it vertically. So that's kind of cool. All right, so now I'm going to delete that one, and I'm going to enter the sine of 3 theta. Okay, so unlike the vertical stretch, so let me get rid of this one, what it's going to do now is it's going to say, instead of having one complete cycle by the time I get to 2 pi, now I'm going to have 3 complete cycles by the time that I get to 2 pi. And now when I graph, here's the original, there's sine, and now here comes the other one. So this is pretty cool. All right, and then I'll help you count on our calculator. So notice I have 1, 2, 3 complete cycles by the time I get to 2 pi. And notice, since I didn't change my amplitude, that the top and the bottom are still pinging at the same values. So that's kind of a cool illustration about what happens as I change the different variables in my graph. All right, so not to waste paper, I'm going to write 6 steps to graph by hand. And this will be the process that I expect you to use as we graph sine and cosine. Tangent's a different beast. All right, the first thing that you always do is determine your period. Okay, we have a handy-dandy equation that says the period is equal to the original cycle divided by the number of cycles. And so that will tell you the horizontal length of your period. And then you're going to mark this on your horizontal axis. Okay. The second step is I'm going to take this period, so I'm going to divide my period in half, and I'm going to label it. Okay. The next step is I'm going to divide number 2, so the step that we just did. So now I'm going to divide technically my period into fourths, But I'm going to take the value that I got in number 2 and I'm going to divide it in half again, and I'm going to label it a B. Okay, and what I mean is if I label my period and then I cut it in half and then I cut it in half again, I would label it. Okay. My fourth step is I'm going to start at the origin. Gosh, I can't spell today, sorry. At the origin. And then I'm going to fill in the missing tick mark. So I'm going to add the missing tick mark. And let me go back to step number 3. I call this your counting fraction, and you'll understand why in a couple of minutes. But this is a really important step to determine what I call the counting fraction. I'm going to use that counting fraction to supply my missing tick mark. So this is 1 pi over 2, 2 pi over 2, 3 pi over 2, and then this is technically 4 pi over 2. Okay. My almost last step is I am going to start at the origin, and I am going to add my amplitude, and I do that to the y-axis. And then last but not least, I'm going to add my points, and then I'm going to connect the dots, which is in essence kind of what your calculator is doing. All right, so let me do some examples, and I'll leave those steps up there as we walk through the first example. So I want you to graph 2 complete cycles. Okay, and I want you to graph y is equal to 4 sine of x. All right, let me skip my paper up just a tad so you may not be able to see all my steps. So the first thing that I'm going to do is I'm going to write down what I'm given. I know that the amplitude is 4, the b is 1, therefore my period, which is 2 pi over b, is going to be 2 pi over 1, which is just 2 pi. So it's still kind of the basic graph. Alrighty, so I'm going to add that information to my graph, and I'm going to do it by hand, so it's going to be a little bit yucky. Alright, so my period is 2 pi. I want to graph 2 cycles, so this is going to be 4 pi. So step number 2 says to take your original period and divide it in half. Well, half of 2 is 1, so this is going to be pi. Step number 3 says divide that in half again, so this is pi over 2. This becomes my counting fraction. That's how I'm going to fill in all of the missing tick marks. I'm going to draw kind of a pink line at 2 pi and 4 pi, so you know that's where each cycle ends. So now I'm going to fill in the missing tick marks. 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. Then this one's going to be 5 pi over 2, 6 pi over 2, 7 pi over 2, and then technically that would be 8 pi over 2. My amplitude was 4, so I'm going to add that to my graph. And I'm also going to use my pink to give me some guidelines, otherwise my curves just ends up totally wacky. So all this is doing is just defining each period, so it has nothing to do with the actual graph. So now I'm going to put my data points on. At 0, sine starts low, high, cross, low, finish. And then I do it again. I start at 0, high, cross, low, finish. Okay, and then I'm going to connect my dots. There's 1 cycle. Here's 2 cycles. And that would be 2 cycles of that particular equation. All right. Let me do another example for you. I'm going to do a couple. The next one again says graph 2 cycles. And I'm going to graph y is equal to the sine of 3x. So again, I always start off by labeling what I'm given. I know that my amplitude is 1. My b is 3. So therefore, my period is going to be 2 pi over b. So that's 2 pi over 3. So this is saying that I'm going to have 3 complete cycles by the time I hit 2 pi. A is positive, so that doesn't change. So now I'm going to sketch my graph. Okay. All right, and I'll use my pink again to help define my areas. My period's 2 pi over 3, so that's going to be the first tick mark that I put on my graph. and then I'm going to put 4 pi over 3 because that would be 2 periods. Okay? So I'm going to add my little vertical lines, and this is just so we kind of understand where one complete cycle ends. I'm going to do half of this now. So I'll do it down here, 2 pi over 3, and if I multiply that by a half, I get pi over 3. And if I take pi over 3 and I multiply it by a half, I get pi over 6. So divide that area in half again. This becomes your counting fraction. Okay? 1 pi over 6, 2 pi, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6. For right now, when we're graphing, you do not need to reduce the fractions because it shows me that you knew how to count. Okay? I'm going to put my amplitude of 1 and a negative 1. I'm going to draw my little pink lines just so I can kind of define my curves. Now I'm going to add my dots. Sine starts low, so low, high, cross, low, finish. Sine starts low, high, cross, low, finish. And I'm going to connect the dots. Sometimes my curves turn out better if I go backwards. And there is 2 cycles of my graph. All right. I have one more example for you, okay? All right, so my next example, or last example, I guess I should say, I'm going to graph 2 cycles, and I'm going to graph y is equal to a negative 2 sine 4 theta, okay? So notice a couple of things that are different. I have a vertical stretch factor, so the amplitude is going to increase. The negative is going to reflect the graph, and the 4 says there's going to be 4 cycles by 2 pi. So my amplitude is 2. The negative I'm going to write as a reflection across the x-axis because the negative does not affect the amplitude. Okay, because remember we always talk about the absolute value of A. My B is 4, therefore my period is going to be 2 pi over b, which is 2 pi over 4, which is pi over 2. All right, so now let me start putting all that information on my handy dandy graph. Okay, yours will be better because it's easier if you do it on graph paper. So I'm going to do 2 cycles. So my first cycle is pi over 2. That means a second one would stop at pi. Okay, alrighty. Now I'm going to divide this in half. So pi over 2 times a half is going to be pi over 4. Divide that in half, and I'm going to get pi over 8. This is my counting fraction. So 1 pi, 2 pi, 3 pi over 8. Okay, let me add my pink lines for the end of one cycle. This is the end of the second cycle. So this was 4 pi over 8, 5 pi over 8, 6 pi over 8, 7 pi over 8, and technically that would be 8 pi over 8. All right, my amplitude is 2, so I'm going to put a 2 and a negative 2. I'm going to draw my pink lines again, otherwise my graphs kind of end up going all over creation. And now I have to manage the reflection. So sine starts at 0 and usually goes up, so now I'm going to start at 0 and go down. So I start at 0, low, cross, high, finish. And then I go down first, cross, high, finish. And I'm going to connect my curves backwards. Woo! Okay. And there's that graph. So actually it's really not difficult to graph, but you do have to learn what the original curve of sine looks like. If you forget, you can always re-sketch your unit circle and regraph it, and that helps you know where the points are. All right, so let me give you your problems. Okay. All right. I want you to graph 2 cycles by hand. And on a quiz or test from me, you will always have to have your graphs look exactly like mine. You may not have to have the pink, but you will have to show me the period. you will have to show me that you cut it in half, and then you will have to label the tick marks. And if you'll notice, there are 1, 2, 3, 4, 5 points for each sine curve that have to be on your graph. Okay, and then I want you to label well. All right, number 1, you're going to have y is equal to the sine of 2x. Number 2, y is equal to a negative 3 sine x. Number 3, y is equal to the sine of pi x, so your b is going to be pi. And for number 4, y is equal to a negative 1/2 sine 4x. Good luck with your problems, and I will see you tomorrow.